So let's start with this one. Okay. Just a second. Then let's start with this one. First thing, equation. What's the equation for this reaction? It's propane 1 aldehyde. If you're looking for an equation, so just make sure you can just Google the equation. It's propane 1 concept propane 1 that's C3H7 and which, and plus you've got oxygen and the reactant to form CO2 and H2O. So you got 3 carbon dioxides, 4 water molecules, and I guess there's 6 plus 4, that's 4.5 O2s, right? That's the equation. Now you're given that it's 0.1 moles, right? This one is 0.1 moles. So the question is, what is the final volume of gas measured under room conditions? So 0.1 moles if it burns with how many moles of oxygen is this? Okay, what is this?
0.5.
Okay, so that's 0.5 moles. That's the first thing. Will 0.1 moles react with 0.5? Which one is in excess?
Oxygen.
So how much oxygen is required? It's 0.45 that's required, right? So it's okay, so 0.45 moles. Now 0.1 moles reacts with 0.45 and it will produce how much? It's going to produce 0.3 moles of CO2 and 0.4 moles of water. What is the volume of 0.3 moles of CO2 that's produced? Because that's the only thing that's going to be a gas. So it's 0.3 moles multiplied by 24 dm³. So what do we get for that? That's 7.2 dm³, right?
Yes.
Okay, and there is now he didn't ask which gas. What's the total volume of gas? So that's the product, and there's some leftover oxygen as well. How much oxygen is left over? That's 0.05 moles, right?
Yes.
Uska, if you try to figure out the volume, that's going to be 224 dm³. What do you get for that? That's 1.2 dm³. So the total volume would be 8.4. That's 7.2 of this and 1.2 of the other one. Okay, so is this clear, this question?
Yes, sir.
So I said now there's another type of question which we so we did these types of questions already. So there's another question which is about combustion analysis. For that, I'll probably switch to the board. Now, this one you haven't probably done in quiz, yes. So this one you haven't probably done in your O levels. I mean, you did do kind of get questions very similar to this, but very often you get very large questions in A levels on this. Now, 1 second. चलें यहाँ पे। So now the question related to combustion analysis, it's going to be all questions will be very similar. The question is basically like this: that you've got a hydrocarbon. It's usually about a hydrocarbon, and whenever you burn a hydrocarbon, you pretty much have the same equation. It's let's say I burn methane, right? So I pretty much have the same exact equation, which is that it reacts with oxygen. And when it reacts with oxygen, it's going to produce what? Carbon dioxide and H2O. So every time you kind of have the same exact reaction, and you can balance it out. It's going to be two H2Os and two oxygen molecules, and that's it. If you do any other hydrocarbon, same equation. It's going to be, let's say I burn an alkene, which is CCH6. Okay, that's also a hydrocarbon. If I burn it with oxygen, it's going to produce the same thing. It's going to produce CO2 and H2O. Except that the ratio is going to be different. Over here, it's going to be 3 carbon dioxide, then there's going to be 3 H2Os, and that's a total of 3 2s are 6 plus 3, that's 9 oxygen. So that's 9 by 2. So the thing or the idea is every time when you burn a hydrocarbon, you get the same thing, except that the ratio is going to be different. The ratio, the amount of oxygen that's going to be used, the amount of carbon dioxide that's going to be produced, and the amount of water that's going to be produced, that ratio would always be different. No two hydrocarbons have exactly. Just say the ratio is 2:1:2. In this one, the ratio is 4.5 ratio 3:3. So if you figure out the ratio, so the idea is that you burn something, right? And you figure out what is the amount of carbon dioxide that's produced, what is the amount of oxygen that's getting used up, what is the amount of water that's produced. If you know the mole ratio, you can figure out the formula of the hydrocarbon, right? If somebody is going to tell me that that there is a hydrocarbon that produces 30 cm³ of carbon dioxide, and it produces reacts with 45 cm³ of oxygen, I can be pretty sure that it's CCH6. Okay. Rafa, idea clear? Is this clear? Abdullah, is this clear?
Yes.
So what you do is you need to know the mole ratios of the amount of oxygen getting used up and the amount of carbon dioxide and water. Now, one way to solve one easy way, I mean, you can't make all equations. Now, the problem is, let's say if somebody tells you that the ratio of the ratio that you're getting is something like this, it's 6:2:4. Now you can't go on and make endless equations and then try to figure out which hydrocarbon this is, right? So you can't do that. What you do is you make a general equation and you fit the data on that general equation. The general equation is, you don't know how many hydrocarbon that there is, so it's X carbons and Y hydrogens, and you burn it in oxygen. So when you burn it in oxygen, you're going to get carbon dioxide and water. And when you get carbon dioxide and water, I'm going to try and balance this in terms of X and Y. Okay, by looking at the equations above. Okay, so and they're going to ask you about this equation specifically, the one that we are trying to balance it. So how many carbon dioxide should I have in this one? Like if I have CXHY and I burn it, if I try to balance it, how many carbon dioxides would be produced? What's the number? Rafi, what's the number?
So there is only one carbon. So
remember, there's an X over there. I mean, this X is, if you had, now look at the equation above. If you had 3 carbons, right? So how many carbon dioxides did you have? You had 3 of them, right? So if you have X carbons, so how many carbon dioxides would you have over here? That's going to be
X.
Okay, clear?
yes, sir.
Now come back to how many water molecules would you have?
Y.
Why?
You compare it with the above. If you had 6 hydrogens, right? So you had how many water molecules? You didn't have 6, you had 3. If you had
Y by 2.
Y by 2. If you had 4 hydrogens, on the other side, you had how many water molecules? You had 2 of them, right? So यहाँ पे it's going to be Y by 2. Is that clear?
Yes.
So you had Y by 2. Now the next thing. Okay, now coming back to oxygen. Now balancing oxygen would be hard, right? So how many total oxygens do I have on the right side? Like how many? If you have 3 carbon dioxides, how many oxygens do I have? 6, right? So it's you just double C, right? So over here, how many oxygens do I have? I've got 2x oxygens, right? Is that clear?
Yes.
Let me repeat this. If you have 3 carbon dioxides, that means 6 oxygens, double the amount. If I have X carbon dioxide, that means double the amount, 2x oxygens, right? And similarly, if I have 3 water molecules, that means 3 oxygens, right? So if I have Y by 2 water molecules, that means Y by 2 oxygens, right? So I've got 2x oxygens and Y by 2 oxygens on this side. So that's the total amount of oxygens that I have on the right side. Is that clear?
Yes.
Yes.
So if that is clear, the next thing is look at what happens above that. I had 6 oxygens plus 3, that's 9 oxygens, right? So what number did I multiply over there? It was half of that, right? 9 by 2, right? Either kya tha? I had 2 oxygens plus 2 oxygens, that's a total of 4 oxygens. What number did I multiply there? That's half of that, that's 2, right? So if I have 2x plus y by 2 oxygens over here, the number would be half of this. So this is going to come out to be x plus half of that, right? So it's going to be x plus y by 4. Like if I multiply this by half, this is going to become x and this is going to become y by 4. Is that clear?
Yes.
Achha, so that's your balance equation in terms of x and y, and you have to remember this. Okay, so just remember, just by comparing it, 3. So 3, so that means x over here. Y, 6, that's 3 over here. So that y, then you're going to have y by 2 on that side. How many oxygens do you have? 3, double that, 6 oxygens. You got x, you got double that, 2x oxygens. 3 water molecules, that's 3 oxygens. Y by 2 water molecules, that's y by 2 oxygens. Whatever the oxygens over here, the number over here would be half of that. So we just divide that by 2 and we got this equation. So it's better to remember, because you'll be short of time. So it's better to just remember this equation. Memorize this. This is going to be, this equation would be helpful in all these questions. There'll be direct questions asking you to actually write this equation as well. So, so memorize this equation. Okay, is this clear so far?
I'm not that much clear about this part.
Nate, did you balance? Nate, is the balancing clear?
Yes, sir.
We just did the balancing. So balancing is clear, right? So we're now going to move. So remember the question. We're now going to move towards solving a question with this. So is this idea clear that if you know the ratio, you can guess what is the formula of the hydrocarbon? Is that clear as well?
Yes, sir.
Okay, so now we're going to link this equation with this what we just learned. Okay, so I'm going to bring up I'm going to do a question now, and so where's the combustion analysis? Just a second. Oh, this one. Not this one. Yep, this one. So we're going to try and do this question. Okay, so look at this question. There's an unknown hydrocarbon, right? I said, remember, the moles of all the others are not known. The moles of the first one is 1 mole. So there's one. I mean, this equation. What does this equation tell you? The first one is 1 mole. The rest of the moles are just X and Y. You don't know what those moles are. So we've got this question. They're saying that there's a hydrocarbon, right? And that hydrocarbon is undergoing combustion. So let's call that CXHY, right? So we don't know what this hydrocarbon is. So I'm going to write down the equation. I know that it burns, and the equation for its combustion is this one. So it's X plus Y by 4 O2. And there is going to be CO2, X CO2s, and Y by 2 H2Os. So from memory, I know what the equation is. Now he is specific that what he states is that there is 10 cm cube of a hydrocarbon, right? And it's burning, and it's burning with 70 cm cube in excess of oxygen. So that means it's not 70 cm cube that's burning, that's in excess. So some number less than 70 cm cube. The final gaseous mixture contains 30 cm cube of carbon dioxide. So you got 30 cm cube of this thing, and it contains 20 cm cube of unreacted oxygen. So that means 20 is unreacted. So that means how much reacted? That's 50 cm cube. So the question is mentioned over here. They gave us everything. 10 cm cube reacts with 70, but 20 is unreacted at the end. So that means 50 is reacting, and it produces 30 cm cube of carbon dioxide. And he's asking what is the formula of the hydrocarbon. So based on this, I've previously told you that mole ratio and volume ratio is exactly the same for gases. So that means 1 mole of the hydrocarbon, the first one, reacts with how many moles of oxygen? That's 5 moles, right? And together they produce how much carbon dioxide? They're going to produce 3 moles of carbon dioxide. Okay, is this clear up till this point? Ahmed, Rafi, is this
Yes,
clear?
sir.
Yes, sir.
So the next thing is, you can figure out the formula of the hydrocarbon. Remember, I told you the first one is 1 mole, right? It's 1 mole. Reacts with how many moles of O2? That's 5 moles of O2. So that means X plus Y by 4 has a value of 5. So I mean, that basically means X plus Y by 4 is equal to 5. And it produces X carbon dioxide. Over here, 1 mole is producing how many carbon dioxide? 3 carbon dioxide. So that means X has a value of 3. So based on the data that's given to me, I was able to figure out the mole ratio, that 1 mole reacts with 5 moles. So 1 mole reacts with 5 moles. That means X plus Y by 4 basically has a value of X of 5. And 1 mole produces X CO2s. 1 mole produces 3 moles of CO2. So that means X has a value of 3. Is that clear? And based on this, I figured out what X is. What is the value of 5?
8.
Okay, so we can substitute X in the other one, and that will give us 8. And that's so Y would come out to be 8. So the formula of the hydrocarbon is X is 3, Y comes out to be 8. So that means CXHY is basically C 3 and H 8, right? Is that clear?
Yes, sir. So I'm not getting how did you derive this one?
X plus
Like I got this one, but I'm not getting this one.
So you're talking about this equation, right? You got Y by 2 in X, right? Is that one is clear,
Yes,
right?
Yes.
I said now let's start over here. Compare it with the first equation. How many oxygens do I have over here? 6, right?
Yes, sir.
It's double the number over here, right? So how many oxygens do I have over here? That's 2x, right? Is that clear?
Yes, sir.
So I got so on the right side, I've got 2x oxygens. How many oxygens do I have over here? How many oxygens do I have over here? 3, right? If I have 3 water molecules, that's 3 oxygens, right?
Yes.
If I have 2 water molecules, that's 2 oxygens, right? So if I have Y by 2 water molecules, I've got Y by 2 oxygens. So I got 2x oxygens over here, I've got Y by 2 oxygens over here. So the total number of oxygens is this much. Is that clear?
Yes, sir.
So then the number of oxygen over here and on the other side, they must be balanced, right? So if I have 6 oxygens over here, this equation, If I have 6 oxygens plus 3 over here, that's a total of 9 oxygens on the right side, right? So what number do I multiply over here? That's 9 by 2. Half of that, right?
Yes, sir.
Over here, if I have 2 oxygens and 2 oxygens over here, that's a total of 4 oxygens, right?
Yes, sir.
So what number do I multiply on the other side? That's half of that. That's 2, right? So
Yes, sir.
if I have these many oxygens on the right side, what number do I multiply over there? That's half of this, right?
Yes.
यहाँ पे 9 था ना, so I multiplied 9 by 2 on the other side. So I've got 2x plus y by 2. So I'm going to multiply half of that. So what is half of that? That's x plus y by 4.
Okay, sir. Got it.
Okay, but it's better to just memorize this because it's going to be very time consuming to derive this during your exam. And is the question clear?
Yes.
Yes, sir.
अच्छा plus अच्छा plus the other one. Okay. So remember they'll have a similar question. They'll mix it up with some other things like I mean it's going to be the same question phrased differently. So just remember. So this one, just remember, okay, where's the board? Acidic gases. Okay, which ones are acidic gases? You got, remember this, that carbon dioxide and sulfur dioxide or nitrogen oxides, right? NO2 specifically, are acidic gases. And they get absorbed by alkalis. And they get absorbed by alkalis. So just remember this point as well, that these are acidic gases absorbed by alkalis, and the alkalis can be NaOH or KOH. So we'll move towards questions now. We'll do more questions now similar to this. So let's try and do another one. This one over here. So I've got this question, and so again, it's an unknown hydrocarbon. So we don't know what the hydrocarbon is. So you've got two options. You can either make equations for each one of them, or you can go for the general equation, which is CXHY plus x plus y by 4 O2s. And then you're going to have x CO2s and y by 2 H2Os, right? So you got this equation. So how many moles of hydrocarbon do you have? That's 0.2 moles, right? So can you figure out the moles of carbon dioxide? That's 35.2 grams. And of water as well, that's 14.4 grams. How many moles of carbon dioxide and water are produced? Okay, has anyone calculated this?
So for carbon dioxide, I think it's 35.2 divided
By 44. So how much is this?
3.
T?
It is 2.93333.
It's 35.2 divided by 44. That's not going to be 3.
Wait, 44? Okay, wait a second.
MR is 44.
Oh, yeah, it's 44. Yes, sir, yes. So it's 0.8.
0.8? 0.8 moles, right? And water as well.
Point 8.
Point?
8. Same as the carbon dioxide.
Now, based on this, remember the first one has to be 1 mole. So what's the ratio? If the first one is 1 mole, that's going to be divide everything by 0.2. What do you get? It's going to be 1 ratio 4, right? Is that clear?
Yes, sir.
So this one is simple. So what is X? So 1 mole produces X carbon dioxide. That's 4, right? And 1 mole produces Y by 2 H2. Y by 2 has a value of 4. So Y by 2 is basically equal to 4. So Y would be 8. So it's going to be C4 and H8. Okay. Is this clear?
So wait a second. Yes, sir.
1 mole produces 4 moles of carbon dioxide, right? So X has a value of 4. 1 mole produces 4 water molecules. So Y by 2 has a value of 4. So hence Y would have a value of 8. Clear?
Yes, sir.
So then, so we have other 3 structured questions, right? We have other structured questions. Page 70. So these ones. Now, this is a similar question, but this one has a longer story to it. So structured questions that the kind of more, and just make sure you're able to comprehend the story. So they're saying, so the equation is not exactly the way we've balanced it because there's an O over there as well. We don't care about the O, but the question would be solved in the same way. So the question is that there's an alcohol and it has a and it's a gaseous sample, right? So it's 20 cm3. And the formula is CXH by O. So this one is 20 cm3, the first CXH by, right? And it says that it reacts with 200 cm3 of oxygen, but that's in excess. So that means it's not really 200 cm3. It's going to be something less than 200 cm3, but it's in excess, right? So I'm not really sure whether what is the amount of oxygen that's used up. The final volume. So the sample was completely burned, and the final volume measured under the same condition as the gases. So the final volume, and you have to be very careful. Be careful. What is the state of water at 120? Is it's a gas, right? So be very careful about that. क्योंकि वो जो mole ratio वाला चक्कर है ना, mole ratio and volume ratio being exactly the same. That only applies to gases. So over here, remember it's 120 centigrade. So that means water is going to be gaseous. So we're going to try and do this. Okay, final volume, right? So we're talking about the final volume, that's 250 cm3. That is what the question is stating. But is this clear? Okay, 120 centigrade water is going to be treated as a gas. Is that clear, Rafi Abdullah? Is this clear?
Yes, sir.
Yes,
remember, and remember that gas volume ratio and mole ratio is only applies to gases. So over here, water is definitely a gas. The sample was completely burned in the final volume. What does the final volume contain? What's this 250 cm3? It contains carbon dioxide, right? It contains water because it's in the form of steam. And what else does it contain? It contains the leftover excess oxygen, right?
Sir, the question is that the gaseous sample was 250 centimeters. So shouldn't it be initial volume?
You got the gas?
So
He's saying that the sample was completely burned in excess oxygen, right? And the final volume was measured under the same condition as the gaseous sample was. Saying that the conditions are the same. Because gases ka hota hai ki if you change the conditions, then the volume will increase. Even if you don't do anything, gases can expand and they can compress, right? So which is why they always mention that the conditions are the same. Is that clear? So after the burning, the final volume of the gaseous sample was 250 cm3. So after the burning, once you burnt it, it contains carbon dioxide, it contains water, and it contains the leftover oxygen, right? Is that clear?
Yes, sir.
Yes.
So under these conditions, he's also mentioned clearly that water is in the form of vapor, and removal of the water vapor from the gaseous sample decreased the volume to 170. So when you got rid of the, sorry, not this one, when you got rid of the water, this one. So when you got rid of the water. So the volume decreased to 170 cm3. So how much water did you have?
80 cm.
Okay, so you had 80 cm3. So I figured out that it's 80 cm3 of water, right? And then he says that treating the remaining gases with concentrated alkali to absorb the carbon dioxide decreased the volume to 110. So when you got rid of the carbon dioxide, the volume decreased to 110 cm3. So how much carbon dioxide did you have?
60.
60.
Okay, so you had 60 cm3 of carbon dioxide. And what is that 110 that's left at the end?
Oxygen.
Okay, that's the oxygen. So the amount of oxygen that actually got used up was 90 cm3, right? Out of the 200. Because 110 is still left at the end. You added 200 initially, right? In excess, and you still have 110 at the end. So that means there's 110 in excess, which means only 90 was actually taking part of the reaction. Is that part clear?
Yes, sir.
Yes.
So that's it. So basically, did you understand the story that you'll get a question where you had to just remember that the alkali absorbs the carbon dioxide or any of the acidic gases. And one second. So the alkali absorbs all the carbon dioxide and the acidic gases. Water, they already told you that they clearly stated everything in the question. And you've been able to figure out the ratio. Calculate the value of y. So what is the value of y? What is the ratio that you're getting? It's 2:9:6 ratio. Now the first one has to be 1 mole. So if I do the ratio, it's going to be 1 ratio 4.5 ratio 3 ratio 4. Is that part clear? Because in the equation, the first one is 1 mole. So 20 cm3 reacting with 90, producing 60 and 80 of this. That's 1 ratio 4.5 ratio 3 ratio 4. Is this clear?
Yes.
Yes.
So what is the value of z? That's 4.5. What is the value of x? That's 3. What's the value of y? That's y by 2 is 4. So y is basically 8. And so complete the equation for the complete combustion of the alcohol. We've been able to figure out the alcohol that's y is 8 and x is 3, right? So it's basically C3H8O. So I'm going to write the whole equation now. C3H8 and O plus 4.5 O2s. That's basically 9 by 2 O2s. And the products are going to be 3 CO2s and 4 H2Os. Then you can see that it's already, the equation is already balanced. ठीक है, clear? This one.
Yes.
Yes.
And that's, you can leave that out. So try doing these questions now. The ones on page 70. The one related to combustion analysis. And make sure when you're finding the ratio, the first one has to be kept 1. It would be wrong if you took the ratio as 2:9:6:8, because in the equation that you balance in terms of x and y, the first one is actually 1. The rest are unknown. So when you figure out the ratio, the first one has to be 1. Is that clear?
Yes, sir.
So, let's try and complete these questions, the ones over here. On page 70, top पे देखना, the one with combustion analysis, right? So we'll go through more of these questions.
So can you also send the class recording?
The class recording?
Yes, sir.
Okay. So I'll send all of them. I actually noted them down. I'll send them. Okay, everyone.
Okay.
Allah Hafiz.
Allah Hafiz.